Professor Kleinium here. I'd like to do a practice problem with you for stoichiometry, theoretical yield, and percent yield. So sometimes this type of problem comes up. You're asked to find the theoretical amount of product that can be made given a certain amount of reactant. So I'm given 24.8 grams of this reactant, and I'm asked how many grams of product could theoretically be made. This is a very standard type of problem. And then the second part is, if I actually make in a lab 13.1 grams of calcium oxide, what's the difference between this amount and the theoretical amount, and therefore what percent yield did my lab result have? Was it 100% of what I expected, 95%? So starting out with this first part, what is the theoretical yield of calcium oxide? Start out with a given here, 24.8 grams of calcium carbonate. First step is to convert that into moles of calcium carbonate. So 1 calcium, 1 carbon, and 3 oxygens weighs 100.1 grams of calcium carbonate, results into 1 mole of calcium carbonate. Okay, the next step is to check the mole ratios between calcium carbonate and calcium oxide. I notice it's a 1-to-1 mole ratio. So 1-to-1 mole ratio, 1 mole of calcium carbonate produces 1 mole of the product calcium oxide. And then I need to convert moles of calcium oxide into grams of calcium oxide. So I know that 56.1 grams of calcium oxide is 1 mole of calcium oxide. So doing the math, 24.8 divided by 100.1 times 1 divided by 1 times 56.1 gives me a total of 13.9 grams of product calcium oxide. So that's the first answer, is what is the theoretical amount of this I can make given this amount of reactant. But the second question is, if I do a lab, and typically you get a little bit less in the lab than you do theoretically, something is lost or something doesn't react completely. So then I notice I have a result of 13.1 grams of calcium oxide, less than the theoretical maximum. So then I use the formula for percent yield. Again, this is the theoretical yield right here. This is what we call the actual yield. The actual is what happens in the lab. So I need to take and utilize this formula. It's the actual yield divided by the theoretical yield and after you divide, you multiply by 100%, and that gives you the percent yield. So it's very simple. I just have to take the actual amount, 13.1 grams of calcium oxide, and then divide it by the theoretical, 13.9 grams of calcium oxide times 100. Okay, and that gives me a theoretical yield, 13.1 divided by 13.9 times 100, of 94.6%. So that's fairly typical in a lab result. You don't often get 100%, but this is a stoichiometry problem dealing with theoretical yields and actual lab values and percent yields.